So this is the same example for a vertical motion, object moving in a vertical circle. Example, vertically rotating water bucket. So it also uses the concept of the physics. So if we use the concept of the physics and explain why, if for example a bucket is there which is filled with water, and the water is not falling at this position. If I mention the position A, so this one is position A and this is position B. So in this case, what happened? When you check the forces which are, so for the water to stay in the bucket at the top at this position A, the reaction force on the water should be greater than or equal to 0. So at the top, because what happened, the normal contact force is always perpendicular. So if this is a bucket and it is filled with water, the weight is acting down, and the normal contact force is acting up, because the normal contact force is always perpendicular. But what will happen if it is at the top, like other way around? So the weight of the water is acting down. And what is the normal contact force? The normal contact force is always perpendicular to the surface. So normal contact force is also acting down. So weight is there, which is acting down. A normal contact force is also acting down. So as both forces are acting down, if I say what is the centripetal force? So centripetal force, or the force which is acting towards the center, is equals to weight of the water which is inside the bucket and the normal contact force. For a minimum centripetal force, minimum force which we require to move this object in a circular path. So for a minimum centripetal force, the normal contact force should be 0. So if the normal contact force should be 0, this is for minimum centripetal force. If normal contact force is 0, so I can say centripetal force is equals to weight. Centripetal force is mv square over r, and weight is equals to mg. M will cancel with m. So v square over r is equals to g, or v is equals to under root of rg. So what this gives the minimum speed at which we should move the bucket so that the water will remain inside the bucket and it will not fall. Because if the centripetal force is more, then what will happen? It will move or downward, or it will come out from the bucket. Is it clear? The force which this is the speed which we require to move this bucket so that the water will not come out from this bucket. So at this position, like if I hold a bucket vertically up, so what happened? The weight is more, or centripetal force is more, the water will come out. If I move at a very high speed, then what I will observe, that the water will not come out from the bucket. And this, if we want the minimum centripetal force required, or speed for a minimum centripetal force that the water will not come out, that's given by square root of r and g. So copy this as well. This is important part. So example, a ball of mass 0.3 kilogram is attached to a string of a length 0.5 meters. So length of a string is actually a radius of the circular path, and swung so that it moves in a vertical circle. When the ball is at its highest point, it move at a speed of 5 meter per second. So it is moving at a speed of 5 meter per second at the highest point. Find the speed of the ball at the lowest point. What you can do, you can also use the conservation of energy concept for this, because the total energy is conserved. So we can use the conservation of energy. If I say this is the ground, like, because we have to assume that one part is origin. So example, this is the origin. So with respect to origin, object at highest point, which form of energy it will have? It will have potential energy and it will have kinetic energy. Is it clear? Why it will have potential energy? Because with respect to the lowest point, it is at certain height. So it will have potential. And because it is moving also, so it will have kinetic. And for a conservation of energy, if energy is conserved, the potential energy, the total energy at any point will be same. And in the question, they did not mention that the energy is lost. So what I can say the total energy is conserved. So if I mention the highest point as A and the lowest point as B, which form of energy it will have? Because at lowest point, it will have only kinetic energy. It will not have any potential energy. So what I can do, I can say the total energy at A is equals to total energy at B. So energy at A will be equal to energy at B. What is the total energy at A? The total energy at A is the potential energy plus kinetic energy. What is the total energy at B? The total energy at B is only the kinetic energy. How to find potential energy is mgh. M is the mass of the object, 0.3 multiplied by gravity, which is 9.8, and multiplied by height. What is the height? Because the length of the string is 0.5. So if this is 0.5, this will also be 0.5. So it is at a height of 1 meter. So this will be 1 plus kinetic energy half mv square. So 0.5 mass is equals to 0.3. And v square, the speed at which it is moving, so 5 square is equals to 0.5 half mv square, that's 0.5 into 0.3 and then v square. So we will solve this equation and we will get the speed at which it is moving in a at position V. Is it clear?
Yes.
So basically what we use a conservation of the energy to solve a question in which we need a speed at a certain point. So you will use the same concept for a conservation of energy. You will use to find a speed from one point to another. So that is done. This is the final. The solution is there. Already I discussed with you. The next part, the tension will be largest at the lowest point since it has a supply the centripetal force and overcome the weight. And it will be smallest at the highest point since the weight is there, which is also contributing to the centric. And if a question is calculate the tension at highest point and the lowest point. So if you want to calculate the tension at highest point and tension at lowest point. So if I need a tension at highest point, so the forces which are acting, the weight is acting down, the tension is also acting down. So centripetal force is equals to weight, which is mass into gravity, plus tension. Centripetal force, how I can find centripetal force? The formula to calculate centripetal force is equals to mv square over r, where m is the mass, 0.3, v is the speed at which it is moving, it's 5, the square you will do, and r is the radius of a circular path, which is 0.5. So you will get the centripetal force, mass and gravity are there. You can find the tension. For the lowest point, what will be the centripetal force? Because centripetal is a resultant force. So which is equals to T minus W or T minus mg. So if I need T, a tension, so centripetal force plus mg. Is it clear? This is the same concept, the vertical circle, the object is moving in a vertical circle.
Clear.
And you can see at a lowest point, we need a 30 Newton force. And at the highest point, we need a 12 Newton force. So which point likely it will break?
The lowest point.
The lowest point it will have, like, because the tension in the string is more. So, or we need a greater force to move the object in a circular path. Resultant force is same at all the points because it's moving in a circular, but that force which we need to apply will be higher at the lowest point. Okay, in this question, a small object of mass 200 gram is attached to the end of a light string of length 40 centimeter. The string is fastened at its other end, and the object is set in a motion so that the motion is in a vertical circle. When the string makes an angle 60 degree with the downward or the vertical force, the object moves with the speed u, like any unknown speed is there. Find the speed of the object at the highest point in terms of u. In terms of u, what will be the speed? Any idea? Anyone want to solve? In terms of u, what concept you will use? So, because in the previous example, it was very simple, highest and lowest point. But this time, it's not high, it's at certain position, P. So basically, what we will do, first, what we'll do, we'll take the potential energy at the lowest point will be 0, as we know. And then we'll find height above the point when the string is making 60-degree angle. So how you can find this height above? So it's a bit tricky question, but not difficult question. As you know, it is making angle 60 degree and it is 40 centimeter. So if it is 40 centimeter, it means it is 0.4 meter. Okay. So means this is 0.4 meters. If this is 0.4 meter, the one which is with an angle, the component with an angle, so this will be 0.4 cos theta. So this height is 0.4 cos theta, the total. And this distance like this total is 0.4, and the component which is coming on the angle so the total is 0.4 or 0.4, and part of this is 0.4. This part is 0.4 cos theta. So if total is 0.4 and this is 0.4 cos theta, so what will be the height above it? We'll subtract. So when we'll subtract, we'll get this total height. Is it clear? Because from the center till the minimum, the lowest point, the total height, because that's a radius, 40 centimeter or 0.4 meter. Okay. And it was making angle 60 degrees. So when it was making angle 60 degrees, this is 0.4. How we identify 0.4? That's the length of a string. So the length of a string will not change. So 0.4, the one which is with an angle, that's 0.4 cos theta. And against the angle will be 0.4 sin theta. So if 0.4 minus 0.4 cos theta, so what I will get? I will get the distance I'll get this vertical distance from the lowest point or the height above the lowest point. So that's why first what we did, we got the height above the lowest point, which was 0.4 minus 0.4 cos theta, which is 0.2. Then we will apply the conservation of momentum, because in the previous example, the at this point, the highest point, it was having potential energy and kinetic energy. And the lowest point, it was having only kinetic energy. But in this example, this object will have both energies. It will have potential as well as kinetic. So basically what we'll say total energy at highest point is equals to total energy at point P. And what is the total energy at highest point? It's a potential plus kinetic. And what is the total energy at lowest point? It is potential plus kinetic. The reason why we did the first thing, to know the height above the lowest point. So the potential and the total energy at highest point is equals to total energy at position P. And using this, we will find the kinetic energy. Is it clear, this question? Any doubt?
Yeah.
So total and kinetic plus potential at the top is equals to kinetic plus potential at P. Potential is mgh, but we need an answer in terms of U. So the speed is equals to V square minus 11.76. Same thing, if they ask the second part, in the question they ask, find the tension. So how to find tension? You need this T. So in this case, the weight is acting, the weight is having its component. So you have to resolve the weight into component. That is one thing. Or you can use tension plus mg, because what we can do, the tension plus a simple formula you can use, the weight is acting downward. This tension will have two components, the one which is within the angle, this will be T cos theta, and weight is acting downward. So centripetal force is equals to T cos theta, which is acting up, minus the mg, which is acting down, and we'll substitute in place of this mv square over r. So we can substitute v and we'll get the answer. You'll get the same answer. They use resolving the invert at a highest point, because the question is find the tension at a highest point. So at highest point, as we know, tension and weight both are acting down. So centripetal force is equals to m v square over r. That's a formula for centripetal. But in this question, the centripetal force is equals to weight plus tension. So weight is acting down, tension is acting down. So we'll get the result. And the tension must be greater than 0 at all the time. So we can find the speed using this. We need a minimum value for u. So the last answer here, we can just substitute t should be greater than and equal to 0. So we can find the value for u, which is about 4 meters per second. An object of mass 2 kilogram is rotated in a vertical circle. So object is moving in a vertical circle. This object is there. Actually, what happened when the cord breaks, the object will move in a tangential to the curved path. So it's rotated in a vertical circle on a cord of length 1 meter. So length of a cord is 1 meter. The cord will break if the tension becomes 500. So if tension is 500, the cord will break. The speed of rotation is gradually increased from 0. Find the angular velocity at which the string breaks. So you have the centripetal, it's moving in a circular path and it's in a vertical circle. And what we need a speed at which the cord will break, and basically the angular speed, like change in angle. So this is a likely position where the cord will break because that will have more force. So T is acting up, the tension, weight is acting down, and the result of this two will give us the centripetal force. So centripetal force is equals to T minus W. So first T minus W, tension 500, and the weight, mass multiplied by gravity will get weight, will get centripetal force. And from centripetal force, we have the formula, because we need an angular speed or angular velocity, which is mr omega square. So we have the mass, we have radius, we have centripetal force. So we can find angular speed, which is about 15.5 radian per second. Is it clear? This example?
Yes.
So these are the things, the topic related to circular motion. Now we'll do some questions. This one is January 2010. Is it visible to your screens?
Yes, sir.
Yeah.
Okay. A particle completes 6 revolutions in 4 seconds. The angular velocity in radian per second. One revolution is equals to 2 pi radians. Like one revolution means one complete rotation. What is the answer for this? Question 1. What could be the answer for question 1? B is the correct answer, because revolution you will convert into radian. How? One revolution means 2 pi radian. So 6 revolution will be x radians. You will convert this into radian, and then radian divided by time, you will get the angular velocity, which is in radian per second. This one is January 2010 paper. Kingda K was the highest roller coaster in the world in 2007. A train is initially propelled along a horizontal track by a hydraulic system. It reaches a top. It reaches a speed of 57 meter per second from rest in 3.5 seconds. It then climbs a vertical tower before falling back towards the ground. So the question: calculate the average force used to accelerate a fully loaded train along a horizontal track. The mass of the train is 12,000. This is related to motion as well, because you already took in AS the movement. So what happened? The train is propelled, so train, and it tries move up, and then it returns to the ground. What is the average force? The maximum speed it reached before it climbed is 57. So speed is 57 meter per second at this point. And it took 3.5 seconds to reach this speed. What's your resultant force, average force? What is the average force? Yeah, what's up? Which was yes, 2.5, 2.0 exponent 5. That's correct. So the average force is 2 exponent 5 or 200,000. Basically, F is equals to ma will give you the final answer. Then point X is just before a train leaves the horizontal track. It's just a beginning. And move into the first bend. Complete a free body force diagram to show the two forces acting on a rider at this point. So you can see here, this is a point X is just before it entered. Point X is just before the train leaves the horizontal track and moved into first bend. So this point. So we have to mention the forces which are acting. Because it's just a horizontal movement. When object is moving horizontally, there is no resultant force in a vertical plane. So weight is acting down and the normal contact force is acting up. And you will label weight and normal contact force. 1 mark is for weight, 1 mark is for normal contact force. And the third mark, the length of the arrow should be equal, because if this is just at the start or the beginning of or the moment it just entered the circular track. When it entered the circular track, there will be a resultant force which is toward the center. But when it does not enter at point X, is just before it enters a circular track. That's why both forces must be balanced. Is it clear? Part B.
Yeah.
The mass of the rider is m and the gravity expression due to gravity is g. At point X, the reaction force of a train on the rider is 4 mg. Assume that the vertical, to be vertical, this is referred as a g force. Show that the radius of a track is about 100 meters. So because to move in a circular path, what is the concept? Whenever object move in a circular path, there should be a force acting towards the center. So in this case, example, if there was a passenger there, if there was a passenger inside, that force, the reaction force on the passenger will be more and the weight of the passenger is small. And that is reaction force is 4 mg and the weight is equals to mg. We need a radius of this curved path. So how we can find radius of the curved path? So centripetal force is equals to 4 mg minus mg. So 4 mg minus mg, so centripetal force is equals to 3 mg. And centripetal force is mv square over r. M will cancel with m. So v square over r is equals to 3g. So we have the speed at which it entered, which was 57. We have the gravity, so we can find the radius of this curved path. Is it clear, this part? The second part?
Yes, sir.
Is it clear, the concept? Because what happened, as it entered a circular path, there should be a resultant force toward the center or centripetal force. The reaction force is 4 mg and the weight is mg. That's why the centripetal force will be 3 mg. And centripetal force is 3 mg and speed at which it entered the track is 57. So we can find